All right, so now we're going to move into graphing polar equations. And on this first page, I'm just going to give you like a little preview of some of the types of graphs that you're going to be seeing. So as you look down here, you will see a couple different shapes. They will have some names that we'll talk about here in a minute. But before, again, this page is just really for you to see what you're going to be graphing. It does help to kind of have an idea. So when we start putting these points together, you can kind of have an idea of what the final product is planning on looking like. But in order to do that, just want to let you know, and you'll notice I have the calculator up here. We'll have some of these that we can graph with our calculator, and some that we're going to graph by hand. So when you are graphing polar equations, make sure first off your mode is in polar mode. Okay, and then you have your rectangular or polar coordinates. For your format is going to be polar coordinates. So let's make sure those are set up here. So again, if you're looking at your calculator, you got your mode. I think I'm already in polar mode. Okay, and then next up, you're going to want to change your format to polar coordinates. So we're going to go second, and format is right up here. Follow my mouse. Second zoom, and we're going to change that over to polar coordinates, and that way when you go to your graphs, well, we'll get to that in a second. I need to get my window set up in a function, but you're going to have your polar your polar graphs is set up in there. So that'll be awesome when we get there, and let's go ahead and leave that for just a little bit, and we're going to be able to, as I said, plug some of these graphs in, but we're going to graph them by hand first, and once we graph them by hand, we're going to take a look at them on our graphing calculators as well and be able to do that comparison. So you'll see that screen up there. We'll come back. You can refer to it as you're going through here. So I have some functions up here for us to start graphing. We're going to start with the parent graphs and see what does the parent graph do in a polar rectangular or polar coordinate plane as opposed to a rectangular one. So you have to remember your parent graphs is going to be very crucial for what we're trying to do here. So it's going to start with our cosine function, and if you remember cosine, the starting point, you got either the starting at 0 or 1. So again, obviously we want to know where we're starting, and in cosine, that's going to be at 0, 1. And at this point, we are going by pi over 2 intervals. So we have pi over 2, pi, 3 pi over 2, and 2 pi. So you're going to do your graph by plotting your points. We have this wave that's going to happen. It's going to go from 1 to 0 to -1, back to 0, and up to +1. And our graph is going to look like this. You don't have to do dotted lines. I'm just doing it to make my curve smoother. And having that curvature is going to be important, that you'll realize here in just a minute. Now, in order to convert this over to polar coordinates, one thing that's really nice is that the angle is actually part of our x-axis anyway, so it does make the conversion relatively easy. But we're going to start with these points here, and those points, the first one is going to be 0, 1, just plotting the points. Now I'm going to skip a space. You'll see why. I'll kind of use it later. I'm going to go pi over 4, or pi over 2, I mean, pi over 2, 0. And then I'm going to plot the rest of my points as I go along. So I have that one space skipped. And the next point is pi -1, and then 3 pi over 2, 0, and then 2 pi, 1. And again, I'll have that one point I'm going to leave open for just a minute here. So anyway, we have r theta now we want to figure out. So remember what r is. R is the distance away from 0. So if you're looking at this, the distance away from 0 for our first point, I made that a little too big. Let me get this highlighter a little smaller here. Maybe you can see it better. So I'm going to take that distance right there. That distance is 1. So my radius for my first point is 1, and theta is actually already kind of labeled for us. Theta is going to be 0 radians. That's our starting point. And then we're going to move on. Let's skip that one point here. So I have this one point I'm skipping on both of these. My next point, I'm going to go from 0. And the reason why is I want to know how high, what's my radius here at this point. Well, at this point, at pi over 2, notice I'm not going up or down. I'm not traveling anywhere in terms of my radius. This is actually kind of like the center. So that's going to be 0, and my angle is going to be pi over 2. So there's my second point. Now hopefully you start to notice a trend as you go through this. These points are just being switched as you go through all your points from your trig graphs. So the next point would be -1 pi. And if you kind of see here, I'm going down 1, so that's the distance. That's the radius from the x-axis to that point. And again, it just means you're going left or right on your polar plane. The next point, you see I'm not going anywhere. I'm literally at 0, so it's going to be 0, 3 pi over 2, and 1, 2 pi. So that's going to be a real quick fix for you as you're trying to convert these. When you have your trig graphs, just flip those points around. Now there is one other point in there. I'll come back to that in just a second. But at this point, we are ready, no pun intended, we are ready to actually graph this. So we have our graph right here. Now, because this graph would be really small if I didn't do this, I'm going to make this third circle 1. So this is 1 right up here. So just be aware of that as I'm graphing this, just to make this one a little easier to draw, so it won't be so tiny. So here we go. I'm going to start graphing all these points on our polar axis. So we're going to have the first point 1, 0. So I'm going to have a radius of +1, which means I'm going out here to +1, and my angle is 0, which means I'm not traveling at all. So there's your first point for your graph for cosine. Your next point is going to be 0 pi over 2. And this one is maybe a little tricky, but you're sitting here at 0, and you're taking a point and you're rotating it pi over 2 radians. Now normally that's 90 degrees, but you're at 0. It's got nowhere to go. I mean, you can rotate that, but you're just taking the circle and turning it, and you're not really actually doing anything. So this is my second point. Now the question is, how do you graph this? Do you just do this? Well, no, not even close. Look at your graph. Your graph is a curve, so we need to graph that curve as well on our graph. Now, if you're not sure where that curve goes, you can always do this. See that point I'm missing? I can plug in another point. That other point, you can pick any one that you want. Now this is going to be cosine, so I want to pick a point that that's nice. So I'm thinking cosine of 60 degrees possibly. So that'd be pi over 3. And again, we're looking on our unit circle here. Pi over 3 is 1/2, radical 3 over 2, and 1/2 is our x value. So I can go pi over 3, 1/2, which means if I went to my graph here and I want to fill that point in, this would be at 1/2 pi over 3. So you could plot that point, and after that we'll kind of know the curve, so we won't need to do this. But I can go 1/2 pi over 3. So 1/2 is right in between here, and I'm going to go pi over 3. So if you look at all these angles that I have, there's 1, 2, 3, 4, 5. So there's 5 increments. And actually there's four gaps here. So if you look at these both, this would be 1, 2, 3, 4, 5, 6 gaps. I don't know why I said 4. So there's 6 little gaps. So the increments on this one is going to be 90 divided by 6, which is 15 degrees each. So again, each of these gaps, as I said, is 15 degrees, and that's the same for all the ones because I use the same scale for all my graphs. So I'm going to go 15, 30, and if you go 2 more, that puts you at 60. So it's going to put you on this point right here. So if you're drawing this graph and you're trying to make everything fit, it's going to fit this curve. It's going to be curving this way, and then it's going to come down and touch that point 0, 0. So there's that first set of points on your graph. And we're just going to keep going. We have our next point, which puts us at 0. I already did 0 pi over 2. The next point is at -1 pi. So I'm going to go -1, which means I'm going to go to the left 1, puts me right here, and I'm going to go pi. So pi radians is going to put me right back at this point. So if I graph that, I want to connect the points. It's just, again, that more of that curve, just going the other way. So if you kind of think about it, it's just going to complete this circle. And we have ourselves a circle. And again, if you plot the next point, you'll see it just starts to repeat. So the next point, if I went negative or 0, 3 pi over 2 is going to put me right back here. And 1, 2 pi puts me here. You go all the way around, it puts you right back at the same point. So basically, this graph, not basically, this is what it is. It's a circle. This is a circle. Now notice, again, if you're doing cosine, it's on the positive. I'll just say a circle, which is opens right. It doesn't open, but the circle's on the right-hand side of your curve, or your graph. Okay, so that's your parent graph, basically, for cosine. Next up is you have your sine graph. We're going to do the same thing. And again, the question is, where does this graph start? Well, for sine, it's going to start at 0. And then we're going to start going up from there. So it's going to go to 1, and then back to 0, then to -1, and then to 0 again. So if you plot these points, there's your graph. Again, we're going by pi over 2s. So pi over 2, pi, 3 pi over 2, and 2 pi. And just like we did before, we're going to graph our points. So our first point for our graph is going to be 0, 0, and then pi over 2, 1, and then pi, 0, and then 3 pi over 2, -1, and then 2 pi, 0. So there's that graph, and we're just going to basically, again, flip those points for our next one, for our polar coordinates. So first one is still 0, 0. Then we're going to go 1 pi over 2. And again, remember the concept on this is you're going up 1. That's the radius. And you're at pi over 2 for your angle. And then you're going to be at, the next point is going to be at 0 pi. And then we're going down 1, which is -1. So that's going to be -1 for my radius, 3 pi over 2. And we're back at 0 for our radius, because we're back at this point. So that's going to be 0, 2 pi. So just like before, we're going to go ahead and graph this. Now you can imagine this one is probably going to be a circle as well. You just want to know where it opens. What direction is it going to be? So that's what we're going to find out when we graph it. But we're going to start here at 0, 0. So that's my first point. My next point is going to put me at 1 pi over 2. So I'm going to go out 1. I'll do the same thing where I go out for 3 units represents 1. So I'm going to, at this point, I'm going to go pi over 2. So I'm going to rotate right there. And then we want to figure out again, how did we get there? Well, if you look at your graph, notice it's opening in the positive axis. Positive. So it's going to be, in this case, going right as opposed to left. It's not going to go this way because that's negative. It's going to go positive. So your graph is going to open that way. And then you draw the next point. You'll see I have 0 pi, so I'm back at 0. And again, remember you're at 0, and you rotate a point pi radians. Well, it's at 0 already, so you rotate that point, it actually doesn't go anywhere. So that's why, again, we're going to go right back where we started. Don't make fun of my ugly circle. And this is a circle. And this one is going to open up. And those are your parent graphs, sine or cosine and sine. Okay, so now I want to show you some of these cooler looking graphs. I'm not going to go through all of them, but you can kind of see, we'll look at those parent graphs and things later. But you do have to know how to graph these by hand as well, so we're going to walk through that process with you at this point. And these are the ones that we will show some of these graphs on our calculator. I know I got that calculator up here, so we'll do that here once we graph C. Alright, so in this graph you notice I made my axis a little bit bigger because of my amplitude. So remember, this is my amplitude of 3. And this guy has a period that's changed. It's not 2 pi anymore. So remember, we do 2 pi over b. That's how we find our period. So in this case, our period is 2 pi over 2, which is pi. So again, that's our period. Now that we have our period, I'm going to do my Patrick interval. So the pat interval, which I use to find the x values on my x-axis, I'm going to go pi times 1/4, so pi over 4. So on my x-axis, I'm going to go by pi over 4s. So pi over 4, 2 pi over 4, is pi over 2, then 3 pi over 4, and then pi. And again, this graph keeps going. If we need to graph more, we'll graph more. I mean, you'll see that you may want to do that, but hopefully if we see the pattern, we won't have to go out any farther. But that'll be up to you. All right, so on this one, what we're going to do is figure out, again, where our graph starts. Well, this is a cosine graph, so this point will start at 0, 3. And then we're going to, again, just follow our basic parent graph. We're going to go down to pi over 4, 0, and then pi over 2, negative 3, 3 pi over 4, 0, and pi 3. Again, we're just following that parent graph. It just has a bigger amplitude now. That's the only real difference, which does affect our graph, by the way, so it is a difference. And there's your graph. So let's see what happens now. Well, before we see what happens, let's plot those points. So as we plot the points, again, our first point here is going to be at 0, 3. And the next point I'm going to pick is, again, pi over 4. I will pick, just to help us see this first curve, I'm going to actually plug in pi over 3. Actually, that's too small. I got to do pi over 6. So if I do pi over 6, again, this is 3 cosine of 2x. So I'm going to, my y value would be 3 times the cosine of pi over 6, which, that's fine. 3 times the cosine of 2 times pi over 6, so it ends up being pi over 3. So this would equal 3 times 1/2, or 1.5. And we'll need that point later, so I'm just going to use that to help us get our curve going. But once you're able to fill in the blanks, you don't need to find all these in-between points. You can kind of see what's happening. But I want to get that point in there just so we have it. And here we go. My next point is going to be at pi over 4. So you plug in pi over 4, you get 0. And then you have pi over 2, gives you negative 3. 3 pi over 4 is going to give you 0. And then pi will give you positive 3. So we're going to take all these points and flip them for our polar coordinates. So that's going to be 3, 0. 1.56, 0 pi over 4. I don't know why I said 6 on that last one. That's going to be pi over 6. Then my next point is going to be pi over 2, negative 3. And then 3 pi over 4, 0. And your last point is going to be pi and 3. Okay, so now we're going to go ahead and start plotting these points and see what kind of curve we end up with. So my first point is going to be at 3, 0, so I'll keep the same scale on this one. So I'm going to go 3, 0. So my angle is 0, so I'm not going anywhere. I'm just plotting that point right 3. My next point is going to be 1.5 and then pi over 6. So 1.5 pi over 6. Now remember, these are going by 15 degrees at a time. So it's going to take me 2 of these. That's 30 degrees, which is pi over 6. So I'm going to go 1.5, which is right here. And I'm going to go pi over 6. So it takes me up to that second line. Okay, that'll just help us see that curve on that first one, that first loop that we have. The next point is going to be 0 pi over 4. Now remember, you're at 0. It doesn't matter what your angle is. You're not going anywhere. So there's your third point. And to start this, we have this little curve right here. Okay, so that's where we're currently at. The next point is going to be pi over 2, negative 3. I don't know why I have that. That should be negative 3 pi over 2. So I have these last points all backwards. Sorry, I'll fix those. So these are all wrong. So 0, 3 pi over 4, and 3 pi. I'm sure you're yelling at me there. Okay, the next point again is negative 3 pi over 2. So remember, over here we're going to go left 3. So take this point, and remember we're going, in this case, pi over 2 in a counterclockwise direction. So I'm going to take this point, and I'll go right here. So if you're connecting that curve, what's going to happen is this curve is just going to continue, and it's now going to end up right here. So there's your next part. So that's negative 3 pi over 2. The next point is 0, 3 pi over 4. Remember, I'm back at 0. So again, it doesn't matter what my angle is. So I'm just going to loop this guy back around to 0. And here I am. And I got one more point, and then hopefully you see the pattern here. If not, you may have to plot more points if you really had to. Remember, this graph keeps going, so you can keep plotting points if you need to. But that last point is 3 pi. So I'm at the point 3. So I'm at this point right here, and I'm going to go pi. I'm going to move all the way over to pi. And there I am. And I'm going to get that loop. I'm going to continue that loop. Not as a straight line. And there we go. Now, if you don't see what's going on yet, we are drawing some, what's called a rose. And what happens if you keep going? It's going to look like this. Okay. And again, there's going to be, as you're doing this, so you should be able to see this pattern kind of continue here. It's going to go up. There's one more loop we have to go. You kind of see the angle this is traveling in. It's just going to kind of continue up here, taking you up to this point at 3. I'm going to get our 4 loops, which it will complete right here. And again, once you recognize these patterns, once you start the pattern, you can kind of finish it without having to plot all the points. You just have to get the first couple just to kind of get you going. So that is, again, as you look at these graphs, this one is called a rose curve. So this has a name to it. And I want to show you how this looks on your graphing calculator. Okay, so if I was going to graph this on the graphing calculator, I'm going to come over here. Got our graphing calculator set up. Again, we have already set up in Fuller mode. So we're going to graph 3 cosine of 2x, or 2 theta. And in this case, we just need to go to our window. Now this window I'm going to take out to 2 pi so we can see the whole thing. And I'm going to go, I think our graph on here is pi over 12. You want to have a smaller step here, because if you don't, it's only going to plot those points that you have on your graph and connect them. So if you're going by pi over 4, so I'll show you in a second, it's going to show straight lines because we had to fill in some extra points to see the curve. So when we graph this, you'll notice our steps have to be small, or else, and our graph will still be kind of blocky because of this step. It could be smaller, but it's only basically plotting those points only. Your graph, we went from -3 to 3. So I'm going to go -3 to 3 in your x and y here. And here's your graph. There it is. And again, notice it's kind of blocky because it's only connecting the points. If I change this to, say, just pi over 4, you see the graph you'll get. It's just drawing like the straight lines. That's why you can't even see them, because when we're doing our graph, the only points we were getting if we just did by pi over 4s were these points right here on our axes. So it doesn't know what to do. It's only plotting those points and connecting the dots. So the smaller you make that step, the more accurate that graph is going to be. So like if you made that pi over 24, maybe if that works, you'll see that's a little bit smoother. So make that as small as you can, so you can see the graph. Keep it small, or else your graph isn't really going to show that curve like it's supposed to. Okay. Got 2 more to wrap up here, so let's do these quickly. So here we go. We have 1 minus 2 sine x. So this graph is going to go up 1. So you'll see I'm going to have a vertical shift up here, up 1. And notice this is, again, let me fix this too. This graph normally, when you see it, looks like this: -2 sine x plus 1. So if you didn't see what was going on here, this is maybe why. So remember, this is a reflection. So this is a reflection over the x-axis. So it's going to be upside down. And this 2 is your amplitude. And this 1 is up 1. So we got our sine graph, which normally starts right here at 0, 0, which got moved up 1. So now it's at 0, 1. And we are going to go upside down. So your amplitude is 2, so it's going to take you down 2. Then it's going to take you back to the middle. And it's going to take you up 2. And then back to the middle. And we're going to connect the dots. Just try to get that curvature as best you can. It is a curve, it is not a straight line. Okay, and then the points on this, is the period wasn't changed on this one, so it is going to be pi over 2, pi, 3 pi over 2, and 2 pi. So those things haven't really changed. So I'm going to go ahead and plot these points real quick for our graph. The first point was 0, 1, and then we had the next point at pi over 2, negative 1. And then we had pi 1, and 3 pi over 2, 3, and then 2 pi 1. And again, we're just going to go ahead and flip those points when we do our polar points here. So I'm going to go 1, 0, negative 1 pi over 2. Then we're going to have 1 pi, and 3 pi over 2, and 1 and 2 pi. So now we're going to go down here and graph these points. So we're going to be at 1, 0 to start. And remember, our angle is 0 radians, which means I'm not going anywhere. So you're just going to put your point here at 1. And just don't move it because your angle is 0. Your next point is going to be at negative 1 pi over 2. So I'm going to go negative 1. And then I'm going to travel in a counterclockwise direction, pi over 2. So it's going to bring me right here. Now the question is how do we connect that point? Well, you want to look at your curve and see how that curve is traveling. Now notice this curve starts at starts above the x-axis, and then it travels through 0 and goes below the x-axis. So our graph has to travel above and below that same x-axis. So that means to connect these points, we're going to have to make our curve do the following action. It's going to start above the x-axis, then it is going to go through 0, because so does this graph. It travels right through 0, the radius of 0. So remember, at this point the radius is 0, so I have to go through that point. As I do that, I'm going to travel below the x-axis. So I'm going to travel through this point at 0, go below the x-axis, and I'm going to hit that point. So again, you're traveling above the x-axis, you're going through 0 where your radius is 0, and then your radius is negative. And again, that goes back to the first graphs that we were doing. When I talk about these, if the point is above the x-axis, we would say this is a positive radius. I'll kind of highlight that now. R is a positive number, whereas here R is a negative number. And that's what's happening. It's kind of transitioning from a positive to a negative number in between those points. So that's why my graph is doing what it's doing right now. Okay? You can always plot more points to help you see that, but if you know the curve and understand the process, you won't need to. Next up, we have the point 1 pi. So I'm going to have 1 pi. So I have this point right here at 1, and I'm going to go pi radians. So it's going to bring me over here. So I'm going to have to loop back, and again, notice what it's doing here. As I loop back, do it in my orange, it's going to pass through 0. That's when my radius is 0. So it's going to pass through 0, and then it's going to become positive as it gets to that point. So if you come down here and you want to do the same thing, it's going to loop around. It's going to go through 0 as it becomes positive. So as it gets above that x-axis, and you connect that point. So there's my curve so far. And if you need to plot more points, you do that. All right, next up I have 3 pi over 2. So I'm going to go 1, 2, 3, and then I'm going to go 3 pi over 2. So I'm going to go all the way around, which brings me right here. So this one's a little bit easier to see as we're connecting these points. You're just going to kind of continue this curve. So I'm just going to keep going. So I'm going to come down here and hit that next point. And hopefully you can kind of see the pattern here, but if not, you do have one more point, which is 1, 2 pi, which is this point moved all the way around. It comes kind of loops back. So we're going to take this final point here and connect it. So that is the graph. So this is called, if you look at it, this is a limicon is what you call it. So this is a limicon. It's got a name. It's a funky name, but it's a name. And this one actually is one where they have what's called an inner loop limicon. I'll just probably put that at the very beginning here. So inner loop limicon. And the main thing here is it's not necessarily knowing all these names. It's just knowing the shapes. If you start recognizing these shapes, you can, as you're graphing these, you can just kind of finish the graph once it's started. Okay, and then I got one more here to show, and we're going to be all set. So this last one is y equals 2 plus 2 sine x. I am going to again rearrange it to y equals 2 sine x plus 2. So it has an amplitude of 2, and I have a vertical shift of 2. So I'm going up 2 with an amplitude of 2. So I got my imaginary x-axis here because I'm moving everything up 2. And again, I'm going to go an amplitude of 2. So this graph is going to start at 0, as I normally do, but now that 0 is at 0, 2, because it got moved up 2. And we are going to, again, just use our amplitude. I'm going to go to my next point. It's going to be at 4. My next point is going to be back at 2. And I'm going to go down 2. So that's going to put me at 0. And then I'm going to be back at 2. So if I connect these points, here's your graph. And again, I just want to fill in, again, if you remember our intervals, as long as I'm not changing the period, which I still have not, this is pi over 2, pi, 3 pi over 2, and 2 pi. So this is your graph. This is 1, 2, 3, and 4. Okay, so now we want to plot those points. And again, if we can fill in the blanks in between them, great. If not, you'll have to plot extra points, but I'll fill in the blanks for you here. So this first point is going to be 0, 2, and the next point is pi over 2, 4, and then pi 2, 3 pi over 2 is 0, and 2 pi 2. Again, flip those points for your polars. So 2, 0, 4, pi over 2, 2 pi, 0, 3 pi over 2, and 2 pi. And again, let's see what we get. And as we do that, again, the last little piece is just kind of showing you again one more time how to plug that in on the graphing calculator. And as you're learning, feel free to plug it in the graphing calculator first. That helps you kind of see what the graph looks like. But again, my best piece of advice is to try to graph it with and then check it with the graphing calculator at the end. And once you start recognizing the patterns, then that'll help you see what kind of graph you have. I'll show you where I have the slides where all those different types of graphs and the functions that form them are located, so that you can use that as a study tool. But anyway, let's do this graph first before I show you all that. The first point is going to be 2, 0. So we're going to start right there at 2, 0. And the next point is at 4 pi over 2. So I'm going to plot that one, 1, 2, 3, 4, and then I'm going to go pi over 2, which is 90 degrees in a counterclockwise direction. Puts me right there. And again, we want to somehow try to connect those points. So as I do that, if you don't see what's going on or don't see what kind of graph we have, just again know that it is going to be a curve. And again, your curve starts at 2, 0 and obviously ends up at that, what was it, 4 pi over 2. So again, if you're having a hard time figuring out how to do that, I just want to use this as a good example to kind of show you what do you do. Well, you can always just pick a point in between here, like pi over 4 and see what you get. Even if it's a decimal, it doesn't matter. You can still work that out. So this would be, in this case, if I plugged it in, plug it in pi over 4, I'd have 2 plus 2 times the sine of pi over 4, which is radical 2 over 2. So the 2's cancel, and you get 2 plus the square root of 2, which is 3.4. So you can now plot the point pi over 4, 3.4, which in this case becomes my r theta, because remember it just gets flipped around. My radius is 3.4, and pi over 4 is my angle. So if I was going to do that, I'm just going to come over here, go 3.4, and I'm going to go right smack dab in the middle there. And if you do that, that's going to put you right here. And now you can kind of see that curve. So it looks like it's going to loop this way and work its way up to that point at 4. So there's your first part of your curve. So like I said, if you ever get stuck, fill in the point in between. That will tell you, again, give you a little more insight of how to draw that graph, which is kind of like your theta step. It tells you how many points you're plotting. The more points you have, the more accurate your graph's going to be. All right, so those are your first couple points. And now I'm going to go to 2 pi. So I'm at 2. So 2 pi, I'll put you right back over here. And again, you're just going to continue that curve around. So I'm just going to continue it. Do my best here to write it correctly. There we go. All right. And now the next point is at 0, 3 pi over 2. So you kind of see this pattern. We're going to kind of continue the pattern. I'm going to go through this point and come in and touch right there. And then we get to the point 2 pi. So if you kind of see this graph, this next point 2 pi is going to put me right back here. So the next question you'd have is, okay, does it do this? So that seems kind of weird. Or does it do this, which might seem kind of weird as well. Once you know your graph, you'll know what it's doing. But just like I always said before, if you're ever stuck, pick a point. So we're going to pick a point between 3 pi over 2 and 2 pi. So that a good point there maybe be 7 pi over 4. We'll kind of go down the same road we went last time. So again, I'm saying if you don't know what to do, fill those points in. So we have 2 plus 2 sine x. So this is going to be 2 plus 2 times the sine of 7 pi over 4, which is negative. I should probably put that in there properly. So negative radical 2 over 2. So these cancel, and you get 2 minus radical 2. So about 0.59. Okay, so I come over here, I flip those points around. This point right here is going to be r theta is 0.59. And then we have, again, 7 pi over 4. So again, 0.59, 7 pi over 4. So 0.59 puts you about right there. And we're going to go 7 pi over 4, which is about 315 degrees. Puts me way over here. So it puts me right at that point. So it looks like the curve that we have is going to kind of hit that point and bounce off of it and take you back to where you started. So that is your next graph, which is a one loop limicon. It's got a name. And as I said, there are more. If I want to make this video longer, I could. I'm not going to do that. But just so you know, as you go through this, if I want to graph these, you can always check your graph as well. That's one quick way to do it. But again, if you're doing this by hand, that's how you're going to fill in those blanks if you don't know what they are. But I can always graph this. Go 2 plus 2 sine x. Just make sure your window would fit what we have. So like if you look here, it's not going to be big enough because I only went up to 3. You can change that real quick and make it go up to 4. And again, remember your step needs to be big enough so you can actually see the proper curvature, because if I made that step, pi over 2, for example, you know, that's a terrible step. You're really not, you're going to see a triangle, you know, because it's just connecting the points. So you don't want to have those giant steps, or you want to be able to see your graph. So again, I was doing pi over 24. That usually is good enough to see your graph. So that's a pretty good step to have right there. It's making more points, and the more points, the more accurate your curve is going to be. Okay, so anyways, you're looking at your slides as you go through here. These are some polar parent graphs that you have. These are some of the ones that we did. And again, notice it has the equation that it goes with right here. You got your circles. You know, we were doing our one loop limicon. That's what we had here. Cardioids, basically kind of the same concepts. You can see what equations they look like. And again, you know, you may not memorize all of those, but if you recognize the shapes, once you start plotting those points, that's what I'm expecting you should be able to do. Is like, oh, that's that loop inside the loop. What's that called again? I mean, if you know the name, that's awesome. But make sure you recognize the shapes. And there's some other ones here. These are the roses that we did. And there's also a spiral that we can do. It's a kind of a more basic graph, but here's another one that we can do as well. So again, as you look at these, going through these graphs, these are the types that you're going to see. So make sure you start recognizing them, so when you start graphing and you start seeing those points being plotted, you can kind of fill in the rest of those points. It'll make your work go a lot faster. So at this point, I should be telling you exactly what you're doing next in class. So if you're in class at this time, well, if you're not sure what to do, then ask.